Hello, good morning, students. So today I'm going to do chapter 7.2. So we discuss about trig integrals. So, we are interested in these two integrals. So first one, cosine nx times sine mx. So that is the first integral, and the second one, and integral tan nx times secant mx dx, and dx here. So those two integrals we are interested in this chapter. So we have. So before that, we will do some use substitution method questions, and then we will do more examples related to this. So warm up. So we know that the integral of cosine x. So start with the easiest one. So integral of cosine is sine x plus c. So once you have the integral, take the derivative and see if you get the same answer. So if you take the derivative of sine, you get cosine, and derivative of c is 0. So you get the same answer. That means you have the correct integral. So next, I am going to evaluate this integral, cosine x, sine x dx. So we can use the substitution. So here we use the substitution method. Use the u-sub method. So you need to figure out what you are going to use as u, and then you can convert the given integral to u. So I would like to use sine. If you use cosine also, that will work. In this case, it doesn't matter which one you use, sine or cosine, you will get the answer. So u is sine x. So once you have that, you can take the derivative with respect to x. So du over dx, that is the derivative of sine. So derivative of sine is cosine x, which is, we can solve this for du. So du is cosine x dx, and then we can solve for dx. So I'm going to divide both sides by cosine x. So we get du over cosine x. So that is d of x. Now we can convert the given integral into u. So we have integral cosine x sine x dx. So we can write this as integral. So we have cosine x, and we can replace sine x by u. So we can replace this by u times dx, which is du divided by cosine x. Now we can cancel out cosine x from numerator and the denominator. So we cancel out these two. Now we get integral u du. So we can now we can compute the antiderivative of this. So antiderivative of u is u squared over 2 plus a constant c. Now you can substitute back your u, which is u equals sine x. So you get sine squared x over 2 plus some constant c, that is the integral cosine x sine x dx. So that's how we will use the u substitution method to evaluate these kind of integrals. Now the problem is so these two are from calculus 1. So now in this new chapter we want to integrate following integrals. Now how do we integrate? How do we integrate integral cosine squared x dx, this integral, and integral cosine cube x dx. So we want to do this. So how do we do these kind of integrals? That's the question we have. So in this problem we don't have sine x terms. If we had sine x, then we can use the u substitution method. So there is no sine x term laying around. For a clever u substitution. That's why we cannot use u substitution for a clever u substitution. Now so let's see how we are going to do these two integrals. So we have to use the trig identities. So I will write down some identities that is very useful to do these kind of integrals. So let's write down idea, make use of trig identities. Trig identities that lead to integrals where u sub work. So we can use following trig identities according to the given problem. Then you can use the u substitution and get the answer. So we have following identities. So first one is cosine squared x plus sine squared x equals to 1. So that is the first trig identity. And the next one is 1 plus tan squared x, which is equals to secant squared x. And third identity, so we can write down the given cosine squared x using a cosine 2x term. So we can write this as 1/2 times 1 plus cosine 2x. So that is one possibility. And for the, if we are given sine squared, sine squared x. Then we can use 1/2 1 minus cosine 2x. And if you have sine 2x, then you can use half angle identity, which is sine 2x equals 2 sine x cosine x. So you can use any of these identities to simplify your given integral. So let's consider the first integral that we want, the integral of cosine squared x dx. Example, evaluate integral cosine squared x dx. So I'm going to use this identity, 1/2 times 1 plus cosine 2x. Solution. So we can use cosine squared x equals 1/2 times 1 plus cosine 2x. Now I'm going to substitute this to the given integral, then we can integrate. So we have integral cosine squared x dx. So we can write this as integral 1/2 times 1 plus cosine 2x dx. So we can bring the 1/2 to the front because it is a constant. So we can write this as 1/2 times integral 1 plus cosine 2x dx. Now you can distribute the integral into 2. So you can write 1/2 times, so this would be integral of 1 dx plus integral of cosine 2x dx, and then you have to add some constant plus c. Now we know the antiderivative of 1, which is x. So first integral is easy one. So 1/2 times, so this would be x, plus then we have second integral cosine 2x dx plus the constant c. Now we need to find an expression for this integral, the second integral. Now we need to integrate. We need to integrate integral cosine 2x dx. So what you need to do, you can use the u substitution. So I will show you for this case, and then from the next example onward, I will use the direct substitution, u substitution directly without showing steps, and I will show you how to do that directly as well. So we can use u equals 2x. So use u equals 2x. Then we can take the derivative. So du over dx. That would be the derivative of 2x with respect to x. So we get 2 times derivative of x is 1. So we get 2. Now I can solve this for du, which is 2 dx. And I need to get some expression for dx. So I'm going to divide both sides by 2. So we get dx would be du over 2. Now we can substitute our u and dx to the given integral. Then we can get the expression for this integral. So we have cosine 2x dx, which is integral. So we have cosine 2x. So we can replace 2x by u. So cosine u times dx, which is du over 2. Now remember, 1/2 is a constant, so we can bring it outside and we can take the integral of cosine u du. Now we need to take the antiderivative of cosine u, which is sine u. So we get 1/2 times sine of u plus some constant c1. So that is the integral of cosine 2x dx. Now I can substitute this to equation 1. So let's take this as 1. So this is our integral cosine squared x dx. So then from 1 we can write integral cosine squared x dx. We can write as 1/2 times x, 1/2 times x plus this integral. So we found it as plus this integral would be 1/2 sine u, which is 2x. So replace u by 2x plus some constant c1 plus we have c here. Now I am going to multiply this each term by 1/2. So we get 1/2 x plus, so this would be 1 over 4 sine 2x, and this would be 1/2 c1 plus some constant c. So remember, we can replace c1, 1/2 c1 plus c by a new constant. So let k equals 1/2 c1 plus c. Then I can write down this integral as, so integral cosine squared x dx, that is 1/2 times x plus 1 over 4 times sine 2x plus constant k. So that would be the integral. So that's how you can integrate cosine squared. So if I give you sine squared, for example, then you can use this this identity, sine squared x equals 1/2 times 1 minus cosine 2x, and then you can get the answer. So you have to follow the same method as we did. So if you have time, try that as well, sine squared x, see whether you got the idea. Now I'm going to do another problem. So we are going to integrate, so if we have even power, let's say cosine 4, so we are going to integrate that. So example, so we need to integrate, so evaluate integral cosine 4x dx. So we need to integrate this. So we need to find some expression for cosine 4x, then we can integrate it. Now I'm going to find an expression for that. We need to find an expression for cosine 4x. So I can write down cosine 4x as, we can write this as cosine squared x to the power 2. So if you multiply 2, you get cosine 4x. Now we know an expression for cosine 2x. Since cosine squared x, that would be 1/2 times 1 plus cosine 2x. So I'm going to use this 1/2 times 1 plus cosine 2x. We get, so I can write down cosine to the power 4x as, so let's substitute this whole thing for cosine squared x. So we get 1/2 times 1 plus cosine 2x squared. That would be cosine 4x. Now I can square each term. So we get 1/4 times 1 plus cosine 2x squared. Now we can square these two. So we can multiply 1 plus cosine 2x with 1 plus cosine 2x. So we have 1/4 times. So we multiply 1 plus cosine 2x with 1 plus cosine 2x. Now we get 1/4 times. So I'm going to multiply these two first. So 1 times 1, we get 1 plus, then we multiply these two. So we get cosine 2x. Then I'm going to multiply these two. So cosine 2x times 1, we get plus cosine 2x plus, then I'm going to multiply these two times. So if we multiply these two, we get cosine squared 2x. So if we simplify, we get 1/4 times 1 plus, so we can add these two, we get 2 cosine 2x plus, this would be cosine squared 2x. So again we have power, so that will be a problem to integrate. So we need to get rid of that. So we know that. So we know that. So we have cosine squared x. We can write it as 1/2 times 1 plus cosine 2x. Now I'm going to, so we need to find an expression for cosine squared 2x. So I'm going to replace x by 2x. So substitute x equals 2x. So I'm going to replace this x by 2x. So we get cosine squared 2x. That would be 1/2 times 1 plus cosine. So if I substitute x equals 2x, we get 2 times 2x, which is 4x. So that would be cosine squared 2x. So this is cosine to the power 4x. So I will take this as star. So then I'm going to substitute our new expression for star. So we get cosine 4x. That would be 1/4 times 1 plus cosine, 2 cosine 2x 1 plus 2 cosine 2x plus cosine squared 2x. So we can substitute this whole thing for cosine squared 2x. So we get 1/2 times 1 plus cosine 4x. So that would be this whole thing. Now I'm going to multiply each term by 1/4 and get the simplified expression. So we can write cosine to the power 4x. So this would be 1/4 plus, if we multiply this, we get 2/4 cosine 2x plus, if we multiply these two, we get 1/8 times 1 plus cosine 4x. Now again I can multiply by 1/8 and get this simplified expression. So we can write this as 1/4 plus, this would be 1/2 cosine 2x. So 1/8 plus 1/8 cosine 4x. Now we can add these two terms. So let's make the common denominator. So I'm going to multiply by 2 and divide by 2. So we get 2/8 plus 1/8. So we get 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. So that would be an expression for cosine to the power 4x. Now we can integrate this, so then we can get the required answer. So we can integral cosine 4x dx. So I'm going to integrate each term. So we have integral 3/8 dx plus, so this would be 1/2 integral cosine 2x dx plus, so this would be 1/8 times integral cosine 4x dx. So if we integrate the first one, so I can bring this constant outside, 3/8 integral 1 dx, and we have 1/2 times integral cosine 2x dx, and this would be 1/8 times integral cosine 4x dx. So now for this integral we have to use u sub, and for this also you have to use u sub method. So if you do separately, if you cannot do this directly, so what you need to do, you can use u equals 2x and find an expression for this integral, and use u equals 4x and get the expression for this. So that will take time. So what we can do, so I will show you how to do this directly. So cosine 4x dx. So we have 3/8 times, so integral of 1, that is x, plus 1/2. So now what you need to do, first find the integral of cosine. So we know that antiderivative of cosine is sine. So you can write sine the given integral 2x, sine 2x. Then we need to divide that by the derivative of inside, which is 2x. So we know that derivative of 2x is 2, so we have to divide by 2. So that would be the integral. And similarly we can use u sub method. So integral of cosine, which is sine 4x, divide by the derivative of inside, which is 4x. So derivative of 4x is 4, so we have to divide by 4 plus add some constant. So that's how we will directly use substitution. So now we can simplify, so we get 3x over 8 plus, so this would be sine 2x divided by 4 plus this would be sine 4x divided by 32 plus some constant. So that would be the integral of cosine power 4x dx. So if you understood this clearly, and if you want to check whether you have the better idea, try the sine power 4x, so then you can see if you have the right idea to do this. Now I'm going to do another example. So remember, we wanted to find an integral. For example, we need to find an expression for integral cosine cube x dx. So for these cases, when we have odd power, we can distribute this cosine cube. So I'm going to write this cosine cube x as cosine x times cosine squared x. So remember, if we have sine term, then we can use, when we have sine and cosine terms, we can use substitution. So what I'm going to do, I will rewrite this cosine squared. So cosine squared as 1 minus sine squared x. So I got this from the first identity. So I brought this sine squared x to the other side. So we have cosine squared is 1 minus sine squared. That's how I got this identity. Now I can substitute that here. So we get cosine x times, this would be 1 minus sine squared x. That is cosine cube x. Now you can multiply each term by cosine x. So you get cosine x minus sine squared x times cosine x. So that is an expression for cosine cube x. Then we can substitute that to the given integral. So then we can find the integral. So we can write integral cosine cube x dx. That is integral cosine x minus sine squared x cosine x dx. Now I can distribute this integral into 2. So I can write this as integral cosine x dx minus, and then integral sine squared x cosine x dx. So again we have to use the u sub for second integral. This for u sub. So I will do that in separately, and then we can substitute that here. So we get so we know that we can use u equals, so this is the most complex one, sine squared. So I will use u equals sine x to simplify that. Then we can use substitution, u sub for the second integral. So we can take the derivative. So du over dx, we get the derivative of sine, which is cosine x. From this we get du, that is cosine x dx. Now I'm going to divide both sides by cosine x. So we have dx would be du divided by cosine x. So that is an expression for dx. Now I can replace sine squared by u squared, because we can write sine squared as sine of x squared. So then I can write down, so integral for cosine cube x, cosine cube x dx. That would be, so we know the integral of cosine x. So first I will write down as it is and then do it later. Minus, so I'm going to write, so this as u squared times cosine x times, so this would be dx, so we can write it as du divided by cosine x. Then I can cancel out cosine x from the numerator and the denominator. So you get integral cosine x dx minus integral u squared du, that would be integral of cosine cube x dx. Now we know what would be the antiderivative of cosine x, which is sine x. So this would be sine x minus, we know the antiderivative of u squared, which is u to the power 3 over 3, and we have to add some constant. So that would be integral of cosine cube x dx. Now we can substitute our u, which is sine x, u equals sine x back. So we get integral cosine cube x dx is sine x minus, so this would be sine cube x over 3 plus some constant. So that is the answer for this problem. So if I give you any odd power of sine or cosine, you should be able to do in this format. So let's write down some notes. So this process works with integrals of the form. So if I give you any integral sine mx times cosine nx dx, so depend on which power is odd, then we will distribute it as we did earlier. Let's say number 1, if the power of cosine is odd, then what you need to do, so you need to write cosine x times the other powers, save one cosine term, cosine factor, and so let's say if I give you sine 4x, sine power of 4x times cosine, let's say 7x. So then you can write cosine to the power 7x as cosine x times cosine to the power 6x. And then you can write, you can use this and use cosine squared x equals 1 minus sine squared. So once you use this, you can use the u substitution to get the integral. Now if the power of sine is odd, so what you need to do, the same thing. So save one sine factor and use sine squared x equals 1 minus cosine squared x. So once you use this, you can get the required solution. The next one, if the powers of both sine and cosine are even, so then you need to use sine squared x equals 1/2 times 1 minus cosine 2x, and cosine squared x equals 1/2 times 1 plus cosine 2x. So that's how we will use. It depends on the form of the problem. So depend on m and n values. So now I'm going to do another example. So we are going to evaluate integral sine squared x times cosine to the power 5x dx. So you can see the power of sine is even and power of cosine is odd in this case. So I'm going to write cosine cosine 5x as cosine x times cosine to the power 4x. Then I can write down cosine to the power 4x as, that would be cosine squared x to the power 2. Now we can use cosine squared is 1 minus sine squared. So I'm referring to this case, 1 minus sine squared. So then use cosine squared x equals 1 minus sine squared x. From that we can write down cosine to the power 5x as cosine x times 1 minus sine squared x to the power 2. Now you can square this. So you can write this as 1 minus sine squared x times 1 minus sine squared x. So I'm going to simplify this as much as we can. So we have cosine x. So if I multiply these two, I get 1. So if I multiply these two, so we get minus sine squared x, and if I multiply these two, I get again minus sine squared x. So if I multiply these two, we get plus. So sine squared times sine squared, so we get sine to the power 4x. So that would be the simplification. So this is an expression for cosine 5x. Now I'm going to substitute into the equation the integral form. So we have integral sine squared x cosine 5x dx. So we are given this integral. So I can write this as, so before that, so we can simplify this further. So we have cosine x. So we have 1 minus, so if we add these two, you can write 2 sine squared x plus sine to the power 4x. So that would be cosine 5x. So I'm going to use this. So then we can substitute to the our integral sine squared x cosine to the power 5x dx. That would be, so we have integral, so we can write down this sine squared term. Now we can substitute cosine 5x as this whole thing times cosine x, 1 minus 2 sine squared x plus sine to the power 4x times, so we have cosine term x and we have this dx. So that would be the simplification. Now I am going to multiply each term by sine squared. Then we can get these simplified integrals. So we get, if we multiply these two, we get sine squared x minus 2 times. So if I multiply sine squared with sine squared, we get sine to the power 4x plus, so if we multiply sine squared with sine to the power 4x, we get sine to the power 6x, and then we have this cosine x dx term. So remember, when you see sine term and cosine, you can directly go with U substitution. So use U sub method. So we can use U equals sine x. So let U equals sine x. So those are the complex terms we have. That's why we use sine x term. And then you can take the derivative. So du over dx, you get derivative of sine is cosine x. So we have du, which is cosine x dx. Now if I divide both sides by cosine x, so then we get dx would be du over cosine x. So that would be an expression for dx. Now I can replace all sine terms by u. So we can write down the integral. So I'm going to write the integral sine squared x times cosine to the power 5x dx. So we can write this as integral. So replace sine squared by u squared and then minus 2 times. So replace this sine to the power 4 by u to the power 4 plus this sine to the power 6 by u to the power 6 So we have cosine x times, so I'm going to replace this dx by du over cosine x. Then I can cancel out cosine x from the numerator and the denominator. Then we get this integral u squared minus 2u to the power 4 plus u to the power 6 du. Now we know we can compute the antiderivative of each term, so that would be the integral. So u squared, the antiderivative would be u to the power 3 over 3 minus 2 times, so this would be u to the power 5 over 5 plus, so this would be u to the power 7 over 7 plus a constant c. Now you can substitute u equals sine x, then you get the answer. So this would be sine cube x over 3 minus 2 over 5 times, so this would be sine to the power 5x plus, so this would be sine to the power 7x over 7 plus the constant c. So that would be the integral sine squared x cosine to the power 5x dx. So I will do more examples of this, so then you can get the right idea. So redo these examples. So I know if you are learning this for the first time, this may be a little bit confusing, but if you do this again and again, so then you will get more familiar with this, and you can overcome with it. So again, you can use TA office hours as well as mine, and let me know if you need any tutoring help, so I can get you a tutor. So if you have any questions, let me know. Thank you very much.